Fresh Minds Python for Data Science class. Today we are going to see how in Python programming we can implement the hypothesis testing for binary data. For this we will need to create a Google Colab notebook. So for that you should go on your web browser and you have to type colab.research.google.com. At this link you will find information related, you will find the link of the Jupyter notebook for executing the Python program. Something like this. Here you have to click on new notebook, and once the new notebook is loaded we can give it a name. For example, I will give the name as binomial test. I will click on connect, and this is an optional step, you don't have to do this, but to share this notebook with you I will click on the settings share and anyone with the link. The main thing I will need is data, so I will upload a file in my notebook. This file will be for containing the data which I will be processing with my hypothesis test. So the data is present in a CSV file. You will get a warning like this, you can ignore. Name of the data is studentstatistics.csv. Okay, so this data we will need while we are working with this binomial test. I will close this sidebar. Here I can see that I am getting a tick sign. That means my Python will be executing correctly. I will import the package pandas, and further I will create my dataset as pandas dot read underscore CSV. In this I will write the name of my CSV file, which is student statistics.csv. Just one more thing I will have to add, that the separator of this file is semicolon, and next I will simply display the data present in this file. So I will get a table like this with several columns filled with data. I can see the shape is 55 rows and 50 different columns. That means this survey was of 55 different students. I am only interested in one column, so I will check that column data. The name of that column is GEN underscore gender. So this is the column that stores the information of the gender of that pupil. We can see there are some not a number values, but mostly people are marking male and female. Two types of gender are present in this. Let us see the count. So for that I will type gender dot value counts. This will be giving me the number of male and number of female. Now I come to the research question. Every hypothesis test will have a research question. So that is also the case of the current test. The research question is the number of male and female equal? in the organization. So there is an organization in which there are 34 males and 12 females, and in that organization we want to know if the gender is balanced. This is data of the sample whose total sample size is 46. Population, we don't know how big it is, so we do not know. But from the sample, we have to make a conclusion of the population. If I look at the data, I can see that male is 34, female is 12. I can directly conclude that male and female are not equal. But I don't know about the population. That is the reason I have to apply the hypothesis test. As I said, there are two hypotheses. One is the null hypothesis. Null means no effect. So I will say there is no difference in number of male and female in the population. Then there is the alternate hypothesis. So it is exact opposite of this null hypothesis. There is a difference in the number of male and females in the population. It is not just important, but it is not important to know if male is less or female is less, because we are using a two-sided test. So two-sided test is non-directional. That means it does not inform about the whether it is lesser or greater, whereas the one-sided test will inform about greater or lesser, because it is directional. I will just note that the two-sided test will only say equal or unequal. Now, based on this data, I have to launch the binomial test and I have to find out which hypothesis is correct. So, the goal of the test is either reject null hypothesis or no evidence to reject null hypothesis. So either one thing will happen or the other will happen. One of the two will happen. Either we will reject the null hypothesis or we will say we have no evidence to reject the null hypothesis. It is simple to use the test. Once we have found the count of each category, I will use the SciPy stats library and import the function binom test. Further, in this function there are three things I must specify. One is x, which is count of any one category. Second is total number of samples, and p is the probability for each of belonging to any one category. So x will be count of any category, then n will be sample size, and p is probability to belong to any one category. So now based on this data I am executing the test, and here I have got the result of the test, which is 0.001. So this is known as the p value or probability value. Probability value means this data, does it belong to a population that is balanced. So p value will tell us what is the probability that the data belongs to a balanced population. And you can see the probability is very small. You will multiply this to get the value between in terms of percentage. So you will get 0.1% chance that the sample belongs to a balanced population. Normally our thumb rule is that if the probability value is less than 0.5 or equal to 0.05, then we say that null hypothesis is rejected. Since that is the case here, I will say null hypothesis is rejected. That means the probability of sample belonging to a balanced population is very low. That is the reason the null hypothesis, which is there is no difference, is rejected. Okay, so that is the way we can launch this test. If I launch the test with some other data, for example, I change this to 23, that means what p value will it give? P value of 1. So with this p value of 1, it means that the probability of belonging to a balanced population is very high and null hypothesis cannot be rejected. There is no evidence to reject the null hypothesis. This is the meaning of p value, and that is the use of p value. This kind of result is what we call as a significant result. Okay, so we will say our result is significant, which means that we can create an inference about our population. In this way, you can apply binomial distribution to different questions and get the results, and then make a conclusion about the probability, or the if you can decide whether the null hypothesis will be rejected or not. So that was it about binomial one sample test, how to implement in Python, how to understand the result, and how to apply that result on data. Keep watching the videos, because in the next video we are going to see more examples and more questions about this test and also other tests. Thank you for watching. Have a good day.